Let's get started, if it's okay.
Sure.
Okay, well, welcome, guys. Good evening, and thank you for joining us on this lovely winter's day. The few of us who are online are members of the Westminster Astronomical Society here in Westminster, Maryland. Some of you may be familiar, others not. But for those of you who are not, we're located about 35 odd miles west of Baltimore in a delightful Carroll County. And our club is a little outside of Westminster, Maryland, up on a hill. It's called Bear Branch Nature Center, or the Hashawa Park. We have a planetarium there that normally we would be running shows in this facility. We also have a very nice observatory, which has a Chris 16-inch meet, 16 inch,
14.
14-inch. I'm sorry, very good research grade telescope. It's a compound telescope, and many of our members are trained to use it. And if those of you in the area who are interested in learning to use it, use the observatory. You can reach out to one of us members, or we'll get you in touch with the director of the observatory, who will, of course, have to teach you and sign you off. But it's something that interests you, I would certainly recommend it. At any rate, so the topic here was sort of winter skies. And before we get started, astronomy, as you know, is the oldest science known to man. And those of you, all of us who look up to the skies these days, when we do, we are, of course, unfortunately, many of us live in light polluted skies, but we still see some bright objects out there. Go out a little darker and you'll see certainly many more. But think back to millennia, how the first human on the planet must have felt when he looked up at the night sky, looked up and saw thousands and thousands of bright lights. If you go to what's called a dark sky area, where there are few left in this country, I think the closest to us in Maryland is called Cherry Springs in Pennsylvania, northern Pennsylvania. If you've not been there, it is a treat. You can see some amazing lights, starlight as we call it. So at any rate, astronomy has guided humans over millennia. The astronomy literature is riddled with all kinds of stories of lore. Every culture has its own stories and its own lore, and we don't know how it originated. But suffice it to say that every culture you look at, going back, again, millennia, there are stories related to the objects. You can imagine, as I said earlier, when the ancient humans looked up, I mean, they saw these objects. Over time, they were intelligent enough to recognize that there were patterns. There were certain objects that appeared at certain times of the year, and foretold a season, for example. Told them, it sort of guided them to plant their crops, when to harvest them. So it was over the millennia, it's become an amazing science that started basically just by observation. Very little recorded history is available because a lot of it is destroyed, but it was sort of word of mouth. And the stories originate mainly in ancient Greece and Roman literature. You can go back to Chinese literature, to the ancient American Indians their lore. Last week we were fortunate to have a speaker from Australia who talked about the Aboriginal lore that apparently goes back 65,000 years. That's a long time. And that was a fascinating talk we had. For those of you new here, we do have monthly meetings. Usually they're the second Wednesday of every month, and we have speakers both from our club as well as from the various sort of organizations we have near in and around Baltimore. Many of you have heard of the Goddard Space Flight Center, the Space Telescope Institute, the Johns Hopkins Applied Physics Lab. So we're fortunate that we can draw on speakers, and hopefully those of you interested can at least look in on and listen to one of the meetings. They're posted on our website, which is www.westminsterastro.org. And Chris, if you don't mind putting it up in the chat, that'll be perfect. Thank you. So I think what we'll do today is just sort of orient you to the skies in the winter, which are absolutely spectacular. The next on the agenda, I believe, will be Chris. He's had his telescope already and hopefully connected, where he will point to some objects in the sky, and we're looking forward to that, as long as the clouds don't come in the way. And he'll tell you a little bit more about the scope that he has. And then one of our other members is Kurt, who is going to give us a little bit on Mars. I put Mars up on the screen. If those of you who were looking at the news and who were reading some articles in October, Mars was very much in the news because it was at the closest point to the Earth. It was the closest to the Earth, and it was spectacular. It is still visible. Mars, by the way, just to refresh people's memories, it is one of the terrestrial planets. Our solar system consists of the so-called terrestrial planets and the gas giants. Going back to maybe middle school, you remember my very educated mother just served up some pizzas, served up 9 pizzas, I beg your pardon. Just served us 9 pizzas. So that's the way to remember the order of the planets in our solar system. You'll note that at one time there were 9 planets. Now we have 8. Unfortunately, in 1996, Pluto, much to the consternation of everyone, beloved Pluto was demoted. So we now have my very educated mother just served us nachos. So Pluto is gone. So Mars is the planet that is the 4th planet from the sun. And you probably also aware that there are several NASA and other countries have their explorers and so forth out there. And Kurt will tell us a little bit more about that. Between Mars and Jupiter is the asteroid belt, which are these thousands of tiny to large objects that are rotating around aimlessly, contained in a field due to Jupiter gravity from Jupiter. And there have been space probes, as you know, have gone there, tried to pick up some samples. And I think the cosmogeologists are waiting to have these samples being transported back to Earth, which would be pretty amazing, so that they can tell us a little bit more about formation of the solar system and perhaps the universe. For those of you who are, I'm sure a lot of you are into observing, but just really quickly, astronomy is all about looking up. That's the club's motto. Astronomy is looking up, and we're going to sort of guide you to looking at the objects visible first by naked eye. And I think if you want to get to astronomy, that's probably the best first way to start, is to just get your eyes adjusted in the dark. Give it some time, switch off all the lights, as many as you can, if you're not able to go to a dark spot or dark sky spot. If you are friends with neighbors, tell them to switch off their lights and invite them out too, So they will also take a look what's up there. So get your eyes adjusted. It's called dark adaptation, and start looking and learn to recognize the different patterns. As I said earlier, every season has different objects that are visible, and the idea is to try and recognize, say, what's out there in the spring versus the summer, fall, and winter. And that's how you learn, just to look at the objects. You don't need a fancy telescope, just your eyes. At the very least, try and get yourself a fairly cheap, well, good binocular. They don't have to spend a lot of money, something that you can hold very easily without getting your arms fatigued, because the larger ones are very heavy and of course very expensive and require tripods and so forth. So learn to use the binoculars, get what's called a wide field view, and you can see many more stars. You'll be amazed how many more you can see through a binocular. I mean, it's estimated that by naked eye, we can see about 2,000 stars in the northern hemisphere and about the same in the southern. And when you add a binocular to that, number sort of doubles. So it's worth investing in a binocular. You can carry it in your car. It's very portable. If for some of you are looking to buy telescopes, before you make the investment, first decide whether you're actually going to use it, whether it is, if it's too heavy, too large, unlikely you'll be able to take it out easily. So you won't use it. You'll have wasted all this money. There are good small light telescopes available, lightweight, which are good for seeing the moon, by the way, which is a very acceptable target, and the planets. So you can see some deep space objects with a reasonable telescope. If you have questions, and those of you in the area, or even though or not, certainly reach out to us. Our members are very knowledgeable, and they will guide you to buying your first telescope. There are many sites on the internet that, astronomers are getting rid of some older instruments, instrument machines. So you can get a good bargain, have it checked out by somebody who knows. And, then from there, begin your journey into astronomy. So I'm looking at Mars here, and you can see Uranus. The moon is set. The solar system, well, just real quickly, historically, until I guess the mid 15th century, the people that lived in that time were egotistical enough to think that the Earth was the center of everything, that everything are circled and around the Earth. And in the mid 1400s, along came a very learned man called Nicholas Copernicus, and he sort of was interesting. He did years and years and years of observations just by naked eye and mathematics, and he propounded the current theory or current concept that we were not a geocentric system, but rather a heliocentric system. In other words, everything revolved around the sun, not around the Earth. And if you think about it, it's a pretty amazing feat. And again, if you hark back to history again, there was a Greek astronomer and physicist on the island of Samos called, the name escapes me, but he was actually the first one to say that, oh, nope, the sun, we go around the sun, not everything goes around us. So anyway, Copernicus propounded and the theory of the heliocentric solar system. And fortunately, it was published after he passed on. Otherwise, he would have been, the church would have probably had him killed. This was then confirmed by Galileo, who by then had a very primitive telescope. And of course, then the rest is all history. So let's try and look at By the way, any questions so far? I know I've been talking, but feel free to interrupt.
Just one quick question. Are there any, do you have any members that are pending to get let in?
No, I think everybody's in so
Okay.
far.
All
Yeah,
right, thanks.
sure. So, oh, somebody just entered. There we go. Yes. So the first thing to do is in order to sort of get into astronomy, guys, the first thing you need to sort of get familiar with are the directions, the cardinal points, north, south, east, west. Hopefully, you know which direction your house is facing, and accordingly can then orient selves. Those of you who are, oh well, again from geography, I guess, or those of you who are Boy Scouts or Girl Guides or whatever. North, south, east, west. When you face north, once you find where north is, facing behind you is south, to the right is east, and to the left is west. And our marker for astronomy in the night sky is this star called Polaris, or the pole star, or the North Star. And let me just put up some lines. Hopefully you can see that. Yes, so here's Polaris, which is the north. And you will see there's a constellation called Cepheus. There's Draco, the dragon, the Ursa Major, and there is Cassiopeia. So these constellations are what are called circumpolar constellations. They rotate around the pole star or the North Star. They never set, they're always there. And once you identify Polaris and look around, you will see Ursa Major. And again, those of you who know, I mean, right now it's very low on the horizon, but these two are called the pointer stars, and they point straight to a straight line drawn through them, gets you to Polaris. There's nothing in between. Big Bear, the Little Bear. Cassiopeia was the queen of ancient Ethiopia. Cepheus was her king. And there are lots of stories to be told. If you bear with me, the story of the bears, Ursa Major and Ursa Minor. See, this is how the ancients saw them, looking like a bear. I'm not sure how they figured that out, but well, they said it looks like a bear, and this one looks like the little bear. And the story is from Greek literature, Greek lore, where you remember Zeus was the king of all gods, and he was ruled the entire kingdom and the world. And he had his queen was Hera, and Hera was, of course, Zeus. Just as an FYI, and the ancient lore was very brutal, and there were no kind things happened to people. It's always tragedy, or people got killed and got eaten alive, and so forth. So the story here is that Zeus was the king, and of course, he had an eye for mortal women, and well, he liked the women, and so he came across a beautiful young lady called Callista, and of course, as Hera suspected, they had a child. The boy was a wonderful baby boy, very handsome young fellow called Arcas, and Arcas, was growing up, and when Hera found out that Arcas was Zeus's offspring, she got very angry and she banished Callista into the forest, but she turned her into a big bear. And the bear wandered the forest. Well, say fast forward a few more years when Arcus is a 13, 14-year-old, and he's learning to hunt, and he became a very accomplished bow hunter, and he goes to hunt, and he goes into the forest, and there he sees a big bear ahead, and he says, aha, let me try and kill this bear and take it as a prize. Well, he knocks his arrow, and he's getting ready to kill that big bear when Zeus, of course, he sees everything, and he happens to notice that his own son is going to be killing his own mother. Of course, Arcus didn't know that was Callista that had turned into a bear. And Zeus, with his infinite power, zaps Arcus, makes him to a baby bear. And as the mama bear is lumbering towards Arcus, because she recognized that he was the son, and he pulls him by the hinds and throws them in the skies. And there we see the bears have a tail. Normally bears don't. So that's the story of Ursa Major and Ursa Minor. And lo and behold, that's where the planet, they're called, the constellations, I'm sorry. They're asterisms, I beg your pardon, that's the word I'm looking for. So Cepheus, Polaris, once you know north and southwest. Now, what else is there on the winter skies? Of course, the winter sky is famous for, all right, where are we? Probably one of the most famous constellations of Orion. Orion is very, very recognizable. Still hasn't risen quite yet. You may want to step out. It's just on the horizon, but Orion is this beautiful, beautiful constellation made up of, if you see, it looks like the hunter. He's got a club. He's got this a bow. He's raised his arm, ready to strike Taurus, the bull that's right here. But Orion has these very, very recognizable structure. This is the armpit called Betelgeuse, Rigel, Bellatrix, and Saiph. Orion, and this is the belt of Orion. And right here, if you can barely see, is the sword of Orion. Now, last year in December or so, Betelgeuse became very much in the news because from being one of the brighter stars in the constellation, it became very dim and people were wondering what was happening. Betelgeuse is what's called a super red orange giant, and it's a huge, huge star. If you can imagine, if that was where our sun is, it would extend, the outer rim would extend way beyond where Mars is. So it's a humongous star. It's was thought that it was ready to explode and become a supernova, but it's become brighter now. So we think it was just going through a phase where it kind of was dimming. And if it is a supernova, we're not going to know for a number of years. It's about 640 light years away. For those of you who don't know, light years is, or just to reiterate, it's a way to measure distance of objects in the universe. So Betelgeuse is very, very easy. Take a pair of binoculars and see it's nice and orange, with your naked eyes, orange. Want to focus on the sword of Orion. It's with the naked eye in the dark sky, you'll see little gray fuzz. Take a pair of binoculars, it becomes a little better seen. And with the telescope then, guess what? You see a delightful nebula. A body is called Orion Nebula. It's a huge star-forming factory. It's quite young, actually, in terms of astronomical years. It's about 1,000,000 odd years old. So, but it's a huge star forming factory and worth looking at. As an aside, you've seen images in print and on internet, colored objects, all these, they're that's not what you're going to see through a telescope, guys. Everything's going to look gray. What you see on published are color enhanced, computer generated, digitized. And I think Chris might be able to show something that he's done, and we'll wait for him to come on in a few minutes. So Orion is gorgeous. Please look for it. You can't miss it. And then next to Orion, just a little further this way. Oh, before I forget, you see, or this is Betelgeuse, this is Sirius, and this is Procyon. This is called the winter triangle, okay? And that's easy to spot. Sirius is the brightest star in the sky. Sirius is also called the dog star, or Sirius is the faithful dog that follows Orion as he moves through the sky. Orion, by the way, goes back again, a story is being recognized from ancient Egypt. It was thought to be, Orion was thought to be the soul of Osiris, which is the god of the afterworld, as he moved through the sky collecting dead souls. And the dog followed him. There are all kinds of stories. The Greeks said Orion was one of the most fearful and feared hunters, and he boasted that he could kill and beat anybody or anything in the world. And Mother Earth, or Gaia as she's called, got very upset. So she sent a huge huge scorpion, very poisonous sting, to fight with him. And guess what? The scorpion was able to kill Orion. Orion fell to the ground. And to this day, the two never meet. They never see each other because Scorpius is a summer, so they're 180 degrees apart. Scorpius is a summer constellation. Orion is a winter constellation, so they'll never see each other. Can't forget, just for a couple of minutes, the Gemini twins, Castor and Pollux. Perhaps on Sunday and Monday, you guys had a chance to look out and see what are called the Gemini showers, the meteor shower that originated in this area and were visible quite clearly when the sky was clear. I unfortunately was not lucky enough seeing meteors as like being very patient, and I hope some of you did see the Gemini showers. It was particularly easy to see from what everybody told me because we had no moon. It was a new moon. So that was apparently very delightful. And I'm sure some of you can share the story. So these are some of the winter constellations. The Auriga is another one. I'm not going to take too much of your time because I want to give time to both Kurt and Chris. Kurt, do you want to take it quickly? Or Chris, do you have anything that you want to show in the, that you've got any objects? Kurt?
Well, it's actually clouding up now, so.
Clouding up, uh-oh. So maybe we can wait. Kurt, I can stop sharing and you can take over? Okay.
Is he there?
Yep, I think so. He's sharing his screen, I see. All right, there we go. Kurt, you need to unmute.
There, okay, is that better?
Yep, that's better. That's much better. Thank you.
Okay. Now I'm trying to find my controls. All right. All right, do you see that? See that slide?
Yeah, we can see it fine.
Okay, well, these are some slides that I showed for our astronomy club a few weeks ago when Mars was at its peak. And, you know, Mars is still pretty good, although you're not hearing about it in the news right now. Let's see here. Nope, I don't. Just a second. Looking for something. I'm just trying to get my bearings here. All right, well, let me continue. All right, there we are. So, Doc had already mentioned that Mars was a terrestrial planet, one of the four. Another category that Mars is, it's also called an outer planet. And simply what that means is outer planets are the ones whose orbit around the sun is farther out than Earth's orbit. So the outer planets are Mars, Jupiter, Saturn, Uranus, Neptune, and of course, Pluto. So what this is showing in this graphic is that when the sun is between the two planets, these are their orbits. So here's the Earth, goes around the sun once a year. The outer planet, in this case Mars, takes a little over 2 years to go around the sun. Is it a little over, a little under, about 2 years. And when the sun is in between the two planets, and in other words, the planet's on the opposite side of the sun from us. I mean, the planet is on the opposite side of the sun. A planet is said to be in conjunction. And the thing about that is they're very hard to observe because they're near the sun. You don't want to be pointing telescopes in the vicinity of the sun because the planet is up during the daytime when the sun is. Plus, it's on the other side of the sun, so it's much farther away from us than it is when the planet is on our side of the sun. So when it's on our side and the Earth is in the middle, and the sun and the planet are in opposite directions, they're at their closest, Earth and the planet. So they're said to be in opposition. And that's what happened this year with Mars, was it reached opposition. Now this shows here's the advantage of why it's important. Different oppositions, Mars will be closer to Earth than at other oppositions. And the reason is because of this blue graphic here, which shows the two orbits. Earth is the blue circle, Mars is the outer orange circle. And what you can see here is that when they do line up in their opposition, some years they're closer than at other times. So here back in 2012, they were farther apart than they were here, say this last October, where they were 38.6 nautical million miles apart. So as you see in this graphic, the Earth's rotation, you see Earth's rotation orbit around the sun is a lot faster than Mars. So you see here the Earth goes around about twice for every one time that Mars goes around. Now this table shows some of the oppositions in recent history and in the future. And you see the ones that are highlighted with red are the extremely close ones. So here in 2020, the distance to Mars was only 38.6 million miles. Back in 2003, Mars was about 4 million miles closer and was appeared a little bit larger in the sky, as opposed to, say, an opposition back in 2012 here, where Mars was 62 million miles away. That's almost twice as far as it is at these closer ones. You see coming up in the next opposition in 2 years, in December of 2022, they're going to be at their closest over 50 million miles apart. So that's quite a difference compared to this year's. That's like a 12 million mile difference. Now, just one thing that most people don't realize is the time of opposition. And opposition is when there are Mars and Earth and the Sun are all in the same plane. That does not necessarily mean that that's the day that Earth is closest to Mars, although it would look like it in this picture. The actual date of closest approach is a few days ahead or behind that. And that's because the planes of the orbits are not, they're inclined to one another. If they're in the same plane, if Mars and Earth's orbits were in the same plane, then the opposition would be on the day of closest approach. But that's actually two different events. You got the day of closest approach and the day of opposition. But now Mars, the interesting thing it does is when it is approaching opposition and the Earth catches up to it in its orbit, like it here, you see when the Earth, in this illustration, when the Earth catches up to Mars, there's kind of an optical illusion. And that is that in the sky, as Mars is moving day by day, it will slow down in its westward progression in the sky. I guess it's actually eastward progression. And it will stop and reverse direction and actually appear in the sky to move backwards. And that doesn't mean that Mars actually stops and backs up. It's a perspective effect. The Earth, which is moving faster around the sun, catches up to Mars and passes it. And in doing so, Mars appears to be backwards. And the analogy to that is if you're out on Interstate 70 and you're going in the same direction with the cars in the other lanes, well, if you're moving a little bit faster than the car the next lane over, as you catch up to it, if you look at it out your window, it will appear in relation to your vehicle to be moving backwards. But you know, you're both actually going in the same direction. It's just an optical effect. And as Mars gets closer to opposition, its size will increase, its apparent size, not the real size. Mars is fixed in its size, of course, just like Earth, but the apparent size will become larger because of the decreasing distance Mars is from Earth. So there's several tools for looking at Mars. One is Sky and Telescope magazine has a what they call a Mars profiler. And when you go there, here's the web address, or you can Google it. Just go to Google and look for Sky and Telescope Mars profiler, and you'll find it. And what that will show you is you can key in a time, and the time you enter is in universal time, which right now it's 5 hours ahead of us. That's the time that all astronomers use. It's similar to Greenwich Mean Time, but that will show you what is currently visible on Mars, the surface features, and this red circle shows you what would be in the middle of the disk. Only problem with this is that it's a square, you know, so you get some exaggerations due to projection, just the same kind that makes Greenland look huge on a map when actually it's not that big a place. But at least this will show you hour by hour what you can look for with a telescope if you have one. Another good source, and Doc was just showing you this, the Stellarium, and you can actually zoom in to Mars and it will show you a representation of what surface features are visible. Not only that, it will also show the two Mars moons and where they are. Typically, you need a pretty big telescope to see the moons of Mars. I haven't actually seen them myself. Not that I've tried that hard, but the one person in our club I know who looks at them regularly, he has a telescope It's a 22-inch telescope, which means that it has a mirror that is a 22-inch diameter. So he's pulling in a lot of light. And not too many people have telescopes like that. But in a small telescope, you can still see certain surface features, such as the polar cap on Mars. Okay, and there's other maps and charting tools that we can use to look at Mars. Now, if you have a telescope, just about any kind of telescope you have will show you something on Mars. Just a hint, though, the biggest um, uh, determining factor is not the magnification, although that is important. But what determines the magnification is the aperture, or the size of the mirror or lens that your telescope has. So if the bigger the aperture, the more light the telescope gathers, the brighter the image it makes, and then it's easier to enlarge the image using different kinds of eyepieces. Small telescopes will make a small image, and when you magnify that small image, it'll just look fuzzy. So if you want to get a really good view of Mars, you need a bigger aperture, if you can get one. Oh, also, the kind of mounting your telescope sits on, if you have an altazimuth mount, which is like a camera tripod, the telescope turns left and right, up and down. Well, as Mars moves through the sky, it's going to rise in the east like this, culminate at its highest, due south, and then set. And that's because of the Earth's rotation. So as the Earth is rotating and you're trying to follow it with your telescope, you'll have to make adjustments, over a little, up a little, over a little, up a little to follow it. Whereas if you have an equatorial mount, which is a mounting that has an axis that's parallel to the Earth's axis, you can track an object in the sky by only moving one axis. Makes it a lot simpler. The polar axis, you just rotate that a little bit as the Earth rotates, and you can keep up. You can also attach a motor drive, and then you don't have to touch anything. The telescope will track automatically. So if you have a telescope, it probably comes with several eyepieces, and the magnification of the eyepiece, the shorter the focal length, the higher the magnification. So if you have one that says it's a 40 millimeter as opposed to like a 10 millimeter, the 10 millimeter will have a higher magnification. Doesn't necessarily mean you're going to see better, because if it's a fuzzy, faint image, it'll just magnify it and make the fuzzy ball look bigger and fuzzier than ever. So high magnification, like they advertise on these telescopes, 400 power, 600 power, usually they're not usable powers. But this illustration kind of gives you an idea of what different eyepieces can show you. Of course, it all depends on your telescope too, the combination of the mount, the eyepiece. Because also, if you have a mount that's wobbly and you have to make a lot of adjustments, when you touch the telescope, if the mount's wobbly, you're going to lose the Mars. It's going to get bumped out of the field. Then you have to find it again. And for that reason alone, it's often good to use a low power eyepiece, because it makes it easier to keep Mars in the field of view. Now, many amateur and professional astronomers also use color filters that can screw into an eyepiece, and they can be used to enhance different elements of the Mars surface. So according to Celestron, you got a blue filter that can help pick out clouds that happen to be there. Green filter is good for looking at the polar caps and dust storms that occasionally occur. A light green, also good with the polar caps. Just different wavelengths of light to bring in different features, and on and on. You got red, orange, and there's all different colors. Some filters that may not work good with Mars might work good on planets such as Jupiter or even Venus. And usually what an astronomer has to do is has to experiment, given his telescope and his eye, what filters work best. So that's it for Mars. I was wondering, do you have any questions, anyone?
Well, thank you, Kurt. That was very interesting. And I'm sorry, the one thing I did not mention during my spiel was a very, very important day coming up on Monday, December the 21st. And Kurt, we can just talk a little bit in a bit, but it is being labeled as the Great Conjunction. The Great Conjunction of the two largest planets, Jupiter and Saturn. So the conjunction is when they're coming close together. This is very, very, I guess, rare. The last one occurred, I think, in the 13th century, about 800 years ago. And if you've been looking out, if you've been reading about it and looking outside in the sort of west-southwest, you see the objects that are coming closer every day. And on December 21st, they will be at their closest. Now, it's going to be fairly early in the evening. I would look out soon after sunset in the west-southwest, and have a pair of binoculars. I think you will be able to see it better. You'll be able to see the two separate. And thank you. Kurt, are you bringing that up?
Yeah.
Oh, thank you. So, and the nice thing about these software, you can plug in any date, time, and we should see it. For those of you who want to view it remotely, I'm not sure what the weather is going to be like on that evening, but our friends, Dr. Peter Plavchan, who's the director of the observatory at George Mason University in Fairfax, Virginia, they have a 32-inch telescope, and they're going to be live streaming it. And if you are interested, just go to George Mason University, and apparently it's going to be put fairly prominently on their site. Don't wait too long, because it's not going to be visible for too long during the night, in the evening. And weather permitting, I would surely encourage you to take a view. It's called a Christmas star, or it's called a solstice star, because the winter solstice starts December 31st. So that would be one event to put on your calendar, set an alarm, and make sure you step out and take a look. So
yeah.
I think.
Oh, by the way, Doc, this shows at like around 5:45 or so.
Right. So you can start looking at 5 o'clock. I mean, that's when the telescope at GMU is going to be starting to track it. So maybe it'll be a little later, yeah. But
Plus, with the telescope, you should be able to see the moons of Jupiter.
Absolutely. Yes.
And Saturn, probably in the same eyepiece.
Yeah, yeah. But if you have a binocular, at least you'll be able to see the two planets separately. And I'm not sure why it's being called a Christmas star. Any thoughts? Anybody? Why? I mean, I know it's near Christmas, I guess. But they're not stars, by the way. They're planets. So that's a misnomer right there.
Well, there's a theory that the Star of Bethlehem was actually a
right. Yeah, I've heard that too. But I don't know anybody that has sort of looked back, calculate whether it was it. My sense it was Sirius, but I don't know. Maybe, who knows?
They found there was one in 7th century BC. There was a conjunction.
Okay.
So it was around that time, but it's hard to say. It was a long time ago.
Yeah. But I think
there's also a couple different conjunction theories. I think in 2 BC or so, there was also a conjunction with, I think it was Jupiter and Venus. So And I think it's not that there was a conjunction. It's sort of in their or in their astrology, in what constellation or
Right, right,
sign did this conjunction occur,
right. Yeah.
and it
But
was in one that might have been associated with Israel or
yeah.
Judea.
So for some of the people who've not been on this program, astrology is not what astronomers are into. So if you're looking for astrology, you're in the wrong place. Just so you know. All right. Well, Chris Nolaka, too cloudy.
Yeah, I was just outside and it's pretty much clouded over.
All right. Well,
It was nice and clear about 3 hours ago, but now it's all cloudy. So
yeah.
I'm not going to be able to show you anything through the telescope tonight. I do have a picture of from the Geminids.
Oh yes, yeah.
It's been cloudy and rainy, so I don't see many Geminids either. But I did catch one that was pretty good.
Okay. Well, let's take a look.
It was just before it started raining.
Uh-oh. So again, for those in the group who don't know, Chris is a very, very accomplished astrophotographer, and he's had some amazing images over the years.
So this is one of the brighter ones.
Oh wow, that's awesome.
That was from the 14th, I think.
Okay.
Like I said, it was just before it started raining, so I didn't get much choice or get much chance to see many Geminids this year. It was a little disappointing, but if you notice all the constellations, if you look close enough, there's Orion, and there's the Pleiades.
Yeah. Oh, the Pleiades. I was going to talk about that, but that's all right.
You got the Cassiopeia over here, and Auriga, and here's Gemini, where you'll notice that the if you trace it back, it comes just right very near Castor, is where the radiant for this meteor shower is. So most of them, you'll see them all over the sky, but that's where they come from, is right around in this area, is where Gemini.
So just while Chris mentions Castor and Pollux, they're called the twins, but they were not quite twin brothers. One was the son of ancient king of and queen of a Greek island. I don't remember, but the Pollux was actually born out of union between the queen and guess who? Zeus. So they were half brothers. That's the story. And when one died, the other was bereft, and as in memory, Zeus put both of them next to each other in the sky, and that's why they're called the twins.
Yeah. I have a video too, if you want to see the video.
Yeah, sure. Anybody, please, those of you who would like to see, stay on. Otherwise, thank you for joining us.
Let me see. Let me see. So it was mostly cloudy the whole night, early in the night, and then it got real cloudy and raining. But if they're around 20 seconds, you'll see two of them. So you got Gemini coming up here in the east.
There you go. Yeah.
Those are airplanes. Those aren't meteors. I have a lot of airplanes here. Oh, there was one, and there was one there. They're very quick.
Oh yeah. Very cool.
Move up here towards the end. And that's when the clouds are coming in. Oh, there was the big one right there. Yeah. And then it started raining, so I went home.
Well, that was very nice. Thank you, Chris, for sharing. And again, in case if anybody else has any questions, please feel free to jump in. Otherwise, we will say good night. Wish you all a Merry Christmas, Happy Holidays, Happy New Year. I'm not sure whether we'll do one in January, but keep an eye out on our website, www.westminsterastro.org. January is usually a business meeting, so that I don't think we'll have anything special on that time. But just as an FYI, I mentioned Dr. Plavchan. He's going to be talking to us sometime in March or April. He's an exoplanet specialist, and we're sort of eager to see what he has to say. So stay tuned. Kurt, thank you very much for the talk.
Welcome.
Chris, thank you. We'll keep in touch. Are we going to put this up on the website too, our club website, or what?
You can just, it's already recorded, so you can just link to it.
Okay. I'll let Tom know.
And,
All right. Well, I'm going to end the meeting, guys. Good